Okay, so when we've talked about percent mass, so we can also make proportionalities, right? So we can sit there and say we can get the grams of calcium to the grams of fluoride. We can get the grams of calcium to the grams of calcium fluoride. We can get the grams of fluoride to the grams of calcium fluoride, right? So, and this is basically just showing you that, right? So we can set this proportionality. So then that means that we can also set up equivalency using those as well, right? And this is what this is just showing. If I can get it to work. So if we had 3.55 grams of calciums, we can calculate how much calcium fluoride we have by just making a direct proportionality or an equivalency using the relationship of grams of calcium fluoride to grams of calcium. And then we use that to cross out and we can come up with our solution, right? Rather than having to go through and calculating the percentage and then using that percentage to calculate that. So we can just do this directly by using proportionality. You guys see that?
Yes.
Okay, so if you don't feel comfortable, you can go the long way. I don't mind. I'll look at it, I'll grade it the same way I would grade it if you went the short way. This is just the short way of doing it. Okay, so let's talk about empirical formulas. I know Ro is excited now, right? So now I can say I officially went over it. Now it will officially be on the exam. So the best way of explaining empirical formulas are the simplest relationships between the elements that are there. So you want to try to get the lowest whole number, integral number between each of the elements that are in a compound. Say, for instance, we have C4H10. So can we divide these by a number and still keep a whole number? Divide them by the same number and keep a whole number.
Yes.
So what number could I divide this guy by?
2.
Okay, so if we divide both of those by 2, what is going to be left?
C2H5.
C2H5. So that would be the empirical formula for C4H10. So the empirical formula isn't that compound, but it is the lowest integral that you can get from that compound, okay? And so it's just a multiple of it. The molecular formula is just going to be a multiple of it, okay? The reason why we use the empirical formula, because often we will use instrumentations to try to determine ratios of carbon to hydrogen, or let's say fluorine to phosphorus in different compounds, okay? So that we can get an idea of what would be the base of that. Let's say somebody poisoned Ryan, you know, because Ryan was getting on somebody's nerves or something like that. Somebody put something in his coffee, Ryan kills over, right? So what a forensic officer would do, they would take a blood sample, they would run that blood sample and look at, you know, elements that are trace elements or trace chemicals that are in there. They'll isolate those chemicals, they'll take fractions and stuff like that, and then they'll run that over like a mass spec. The mass spec will give you ratios of different elements to each other, right? And so from looking at those different elements to each other, you can sit there and determine what would be the empirical formula of a poison. And then you plug it into a database and it'll run through it and it'll find a multiple of it and they'll figure out, say, okay, so it'll probably be cyanide or, you know, something along those lines. Okay, you guys see?
Yes.
Because I remember Jessica, one of the first things that Jessica asked me, this is her question a lot of the times. Am I gonna really need this? Remember that, Jessica?
Yes, I do.
So do you need it, Jessica?
Yes, you do. You need everything in chemistry. Sometimes you even need Dr. Henry, honestly.
Okay. Okay, so let's do a problem since you got the gist, right? Oh, well, before we go, I'm getting ahead of myself. So often we're going to use percent mass, or we're going to use mass itself to sit there and determine. But we don't want to compare mass to mass because it's really hard to compare mass to mass, right? We want to compare quantities because if you look at this, right, this tells me there's 2 carbons to 5 hydrogens. Here, this tells me there's 4 carbons to 10 hydrogens, right? If we look at the ratio, we'll always end up with the empirical formula. It's a 2 to 5 ratio. There's always going to be 2 carbons to 5 hydrogens. Okay, so isn't that quantity?
What was that?
I said, isn't that quantity 2 compared to 5? 2 carbons compared to 5 hydrogens.
Yes.
Right? It's quantity. It's kind of like when we were talking about, oh, maybe it wasn't this class. I like talking about apples and grapes, right? So if I have 2 apples to 5 grapes, right? So I'm always going to have 2 apples to 5 grapes. So if I want to keep that ratio, right, and I have 10 apples, how many grapes should I have? Come on.
One.
My ratio is 2 apples to 5 grapes.
20.
So if I have 10 apples.
25.
25.
25. Yeah.
Okay. Okay. So we're comparing quantity, right? We're not comparing mass because we're not weighing those apples, are we?
No.
Right. And so when we look at chemistry, the majority of chemistry is comparing quantity to each other. So when you're doing a chemical reaction, you're saying this compound plus this compound will equal this compound. But if I have one of this compound and one of this compound, I can get one of this compound, right? So it's based upon quantity, it's not based upon mass. So we always have to change from mass to quantity, okay? And you're probably saying, what the hell is he talking about? You know, we went to all of this easy stuff and now we're getting crazy. Well, don't worry. I'm going to show you what I'm talking about, I promise. Okay? So, and then you'll probably still say I'm crazy, but that's okay. So as I was saying, you're going to have to use that mass and be able to change it to quantity, right? How do we change mass into quantity?
You divide.
What was that?
You divide
I divide by what?
mass into quantities. So you divide quantities.
Okay, so for instance, if I have 25 grams of iron, how can I change 25 grams of iron into the number of iron molecules that I have, or iron atoms that I have? Ooh, somebody said your window. It better not be Jessica. Okay, Jessica, I'm gonna beat you. We talked about this.
I'm sorry. I can't, you know, this is chemistry. I really like chemistry.
I can tell, but you're not supposed to give them the answers. I made you guys suffer. They have to suffer a little bit. That's the rule. You guys are lucky. You have Jessica on your side.
Good job,
So
bro.
yes, we're going to use molar mass because we go from mass to moles. And moles
How
is
did I even
quantity,
figure
right?
that out? Dang.
Dang,
Yeah.
cool. That's really cool. See, you have really smart students, Dr. Henry.
No, I read it in.
Yeah, they know
That
how to read the
means that
chat.
Dr. Henry's been calling us dumb if Jess said that.
That I'd be calling you dumb?
No.
Oh my
Right.
God, you guys talk crap about us.
Oh, hell yeah, I do. I'm not going to lie. Okay, Judy, I talk crap about you in front of you. It's not like I don't do it behind your back. I'll tell you.
I love it.
Exactly
I love
what I'm
it.
thinking.
I love it.
Dang.
You know me. I don't pull punches. I let you know. So we were talking about this, right? So now you know molar mass, right? Because moles is just quantity, right? Because remember, dozen. What does a dozen mean?
12.
Isn't that quantity?
Yes.
So moles is just quantity. What is a mole?
6.02 times 10 to the 23rd.
I'm still waiting for the day that somebody comes and just shows me their tattoo of a mole, like on their chest or on their back. See, I got a mole. You want to see my mole? Ta-dum-dum. Okay, it was a bad
like
joke.
also
Yeah, you
laughter?
guys are horrible.
I was
See,
supposed
that's
to
why I
laugh
talk
there.
noise about you. Okay. Okay, you guys ready for this? Are you feeling it? I know Aubrey's feeling it because she was emailing me earlier. She's like, do we have to do chapter, what was it? What chapter was it, homework? Chapter 7 or 8? Chapter 8 homework?
Yeah.
Come on, enthusiasm. Yeah. I'm gonna tell your mom on you. Okay. So here's your problem. Okay, I'm gonna go through it and then we're gonna do another one because I want to make sure you guys have a good grasp on it. But we're gonna kind of go through it together. Okay, as a team, I'm expecting Aubrey to kind of lead the way because I'm gonna make a bet. So Jessica, which horse are you gonna have representing you? I mean, which student are you gonna have representing you since it's a horse race?
Okay. I'll have, I don't know, Dr. Henry. Who wants to represent me? I'll let someone choose.
It's a big title.
Not it. Not it.
What?
I'll have, you know what, Ryan. I trust
Ryan?
you. Yes, because you're the first
Ryan.
one I
So
see on my
Ryan-
screen.
Ryan is your horse, and Aubrey is Cole's horse, right? So we're gonna see which tutor who has the rights, the naming rights. Okay, you guys ready?
Come on, Ryan, make me proud.
Okay. So, but we won't do it for this one. We'll save it for the next one, though. Okay, because I want to get you guys ready. But you guys are ready for this, right? Aubrey, you're ready. You're representing Cole. I'll
Okay.
call him to let him know that you're gonna be representing him.
Ryan,
Yes, Jessica.
No
I'm
pressure.
sending all my positive vibes on you.
Okay.
I'm a gambling man. I love gambling. So it's like this. So we've got to put a little stakes on the table, right? What's the bet, Jessica?
What's the bet?
Yeah, with you and Cole, because Ryan's representing you. This is a title type of thing. What's gonna be your bet against Cole?
I actually don't know. He's gonna laugh when I tell him this. I don't know. Maybe I'll cook him something.
Okay, so Aubrey, you got to let Cole know that he has to cook Jessica something.
Okay.
Okay. So if he loses, he cooks. If she loses, she cooks. Okay. Okay. So you guys pay attention. Now
Hi,
everybody.
Ryan.
needs to pay-
My palms are
Okay.
sweating right here.
And our two.
Okay. So first off, let's start off with what is it that? Let me read the problem, and then you guys tell me what you think we should do. We'll through it. So a sample of pure compound is made up of 1.61 grams of phosphorus and 2.98 grams of fluorine. Find the empirical formula of the compound. So what is it that we want to do?
You want to
Oh.
start off with what you're given?
I want to start off with what I'm given. What are my givens?
The
Yeah,
1.61
too.
gallons of phosphorus,
Okay.
2.98 grams of fluorine.
Yes, Ryan. Woo! Team Ryan.
You're putting a lot of pressure on me, Jessica.
I am encouraging you. There's a difference.
Call this the Tudor Wars. Okay, what is the symbol for fluorine? I'm, still learning chemistry, so you got to help me out here.
S.
Did you say F?
F.
Okay. I thought you said S.
No
Like,
S.
what? What is it? Okay, what about phosphorus?
Dr. Henry,
Yes.
is
ma'am.
it fluorine gas or fluorine?
No, we're just
What type?
talking about, when we're talking about this, we're not talking about the normal element itself. We're just talking about fluorine on the periodic table, right? Because you're talking about the total amount of fluorine, not fluorine gas, because they'll say specifically fluorine gas, and we know that fluorine gas, and that is the natural state of the element, right? But this is a compound composed of phosphorus and fluorine, so it's actually in the compound itself. So we're just looking at fluorine by itself, as in fluorine, the atom, not the element, not the diatomic element. Does that help?
Yes. Thank
Okay.
you.
Good question, though. Okay, so what else? You said 1.161. And what is phosphorus? Something for phosphorus?
30.97.
I said the symbol first.
Oh, T.
Okay. Boy, he is anxious. You got a good horse.
He's not a horse, Dr. Henry. They're not.
Okay. So, and you were telling me that, so I guess Ryan is suggesting, and you can tell me if I'm wrong, are you suggesting that we use the molar mass for something?
Yes.
Okay, so how am I going to use this molar mass? Because you said it was 31 roughly.
30.97 is grams phosphorus, but that's going to be on your bottom because you're doing your equivalency. So you want to cancel the grams for phosphorus out, and you're going to calculate for your mole. So on the top, you're going to put 1 mole phosphorus.
Wait, I have a question. Where did you guys get the 31 from?
Periodic table.
Oh, okay. Never mind.
I
Oh,
just rounded up because I'm lazy.
Good question.
Yes. Oh, did you say good question?
Yeah, a good question.
And we're still keeping sig figs, correct?
That is correct. You're going to be doing sig figs to your old and gray.
Oh my God.
Now, if one of you tell me that you're already old and gray, I'm going to roll my eyes. So, okay, so what do you guys get?
So 0.0519.
And that's moles.
Phosphorus.
Okay, so what about the fluorine?
Fluorine, I believe, is 19.
19.
If we want to keep it in whole numbers.
So we're going to put the 19.
At the bottom, 19 grams fluorine. And that also is going to be 1 mole fluorine.
So Ryan, I mean, I just want to recap, make sure I understand it, since I'm new in chemistry and all. So you're telling me that the stuff on our periodic table, here, so these guys are equivalencies, and I can use them and I can flip them the way I want to.
Correct. So you can flip them to kind of solve for what you're. So they give you a certain, like they're giving you the 1.69 grams or the 2.98 grams, but you're trying to figure out, I believe, the mole ratio for it. So that's why you're looking for the mole. So that's why you use like dimensional analysis to kind of cancel out the grams to find the mole ratio.
Nice. I like the terminology.
Yes. Yes.
So Aubrey, he's showing out. You gonna put him in check?
I think she logged off. She got a little intimidated.
You intimidated her.
No, I'll clap for her too. Go, Aubrey!
Jazz. We don't do that. I'm joking.
Okay, so now we have things in moles, right? So the best way of thinking about this, if you think about what we did before, we found a number that would be common between the two. But here, you know, we have these weird numbers, right? We want to try to get whole numbers. And the best way of getting whole numbers is first try to divide by the smallest number, right? Because that'll give me at least one of the numbers are going to be whole, right? And we want to try to get as close to a whole number as we can possibly get. So what is the smallest number? 0.0519 or 0.157?
10519.
Okay, so you're saying this guy is the smallest number? So if we
Yes.
take this number and divide it by itself, what number are we going to get?
1.
Okay. So that means that we have 1 phosphorus. That looks like IP. Let me make it a 1 looking. Does that look like a 1 to you?
That's
Yeah.
Okay. And then this guy, we divide it again by that same number.
So that would equal
3.
3.01.
So remember, a whole number. We want to try to get a whole number. So is 3.01 pretty damn close to 3?
3. Yep.
Okay. Okay. Piece of cake. So what does that mean? So when we write the chemical formula, that means that we have, or the empirical formula.
It'd be PF3.
Yep. So for every 1 phosphorus, we have 3 fluorine. Piece of cake?
Yes.
I have a question, Dr. Henry.
Yes.
So what if, for instance, on your, you know, your fluorine, you got 3, right? What if you get like 3.6?
Ah.
Right?
So you're messing with my next question, Jessica.
Oh, I'm sorry.
Okay. So you guys see the situation? You got this down so far? And then I'll
Yeah.
answer Jessica's question.
Wouldn't you round up since it's a 6?
What was that?
Wouldn't you round up because it's a 6? It's like a greater than.
What do I round up? Actually, we won't round up, right? Because in this situation, right, you want to try to be as close to a whole number as you are. If you're halfway in between, you're gonna have to multiply by something. Let me give you an example, right? So we're gonna give you the same example. We're just gonna change the number that we have up top. So give me 1 second. Let's assume we're going to change the problem. Getting rid of this. So everybody got this one down? You have a picture of it or whatever you're going to do to it?
Yes.
Lick it, whatever you're going to do.
Events.
So let's assume that we have 3.45. And keep everything else the same. So what number do we get over here?
1.181 or 182.
Okay, 182. Okay, so when I divide 182 by 0.0519, what do I get?
3.5. You get, oh, never mind.
3.51.
So 3.5, okay?
Mhm.
So what can I do to make this a whole number? Now we're not gonna round up, right? Or round down because the number is too relevant, right? So 3.5 times what is gonna equal a whole number?
Okay, hold on.
Times 2. 3.5 times 2 is 7.
Okay, so then let's do that. Let's multiply it by 2. Let me find another color. So what we do to one, we got to do to the other. So we're going to multiply this guy by 2, and we're going to multiply this guy by 2. So this guy is going to be 2p. And this guy is going to be 7f. Is that right?
Correct.
So then my empirical formula is now P2
7.
7?
F7. Now, you can't divide this by anything to make it even lower, right?
Correct.
So that's the reason why you can't just round up like 0.5 or 0.6, okay? You have to try to get it to, the nearest height, the whole number. Now, the way that I've done this, right, I make myself a little cheat sheet because, you know, when you're in a test, you don't want to be thinking too hard. So I know that if I have a number times 0.2, I'm going to multiply that by what to give me a whole number? What is going to give me 1? What number am I going to multiply 0.2 by to give me 1?
5.
5.
Okay. And then what am I going to multiply let's say 0.33 by, or we could just say 0.3 to give me a whole number?
6.
Did you say 6?
Yeah.
6 would be a little too much, but
3.
I thought, yeah, 3, right? Because then that's going to give me approximately like 0.99, so that's 1. Okay, and what am I going to multiply? Let's see, oops, I skipped 1. So if I have 0.25, 4, right? Okay, if I have 0.5, like in this case, 0.66, maybe that'll help a little bit. So what is, do me a favor, 2/3. 2 divided by 3 is going to be what? What is that going to equal?
0.666667.
Oh, really? So if I multiply 2/3 times 3, what do I get? I get 2. So if I multiply this guy by 3, that's going to give me a whole number, right?
I give you 2, right?
Yep, it's going to give you 2.
You're a genius. Wow.
So if I have 0.75, what am I going to multiply that guy by?
Three-fourths? Or
3/4, or if I just multiply it, it's going to be 3/4. I multiply it by 4, right?
Correct.
Is that going to give me a whole number?
Yes. 3.
Okay. And then 0.8. But am I going to multiply that to give me a whole number?
Five.
Okay, so this is my little cheat table, right? So I know that, you see where I have my 0? So if I have 3.5, instead of having 3.5, I have 3.2, then I multiply it by 5, right? So if I multiply 3.2 by 5, what is that going to give me?
A whole number.
A whole number, right?
Mm-hmm. That's so awesome.
Yeah, it's just your fractions, you know. Okay, you guys ready for the next one?
Yeah.
Party. So pretty simple, right? You feeling confident? I'm building you up.
Mm-hmm.
Okay, let's make it a little more challenging. Oh, does that answer your question, Jessica?
Yes, it does. Thank you.
Okay, so here's the question. It says nicotine is 75.1% carbon, 8.64% hydrogen, and 17.3% nitrogen. What is the empirical formula?
Well, you're going to use dimensional analysis again, I believe. So you have to first identify your givens and what elements you'll be working with. We know we're working with carbon, which is 71 or 74.1, and then hydrogen, which is 8.64 grams per hydrogen.
So somebody's been reading ahead.
I'm trying.
It's good. So what Sarah's doing is she made an assumption. She assumed that we had 100 grams of nicotine. So if I have 100 grams of nicotine, how many grams are going to be carbon?
$74.1.
74.1, right? How many grams are going to be hydrogen?
8.64.
And then how many grams are going to be nitrogen?
17.3.
Okay. So Sarah's just basically getting ahead of the game. She said 71.1 grams is carbon.
So we have to do that for all of them.
That is correct.
Am I doing it right?
Yeah,
Yes,
you
you are. The only thing you want to make sure you put your C there on top of your moles so that I don't think you're talking about something else.
We want to ensure our sig figs. So there'd be 3 sig figs. So
So
Is that-
3 sig figs, Sarah. What are your units also? Don't forget, slow down. Finish your units.
What do you mean?
What units would this be? It's 6.175. What are the units on it?
Moles.
Moles of, okay?
Gee. There's not a straight line.
Okay. You're not being pulled over, so you're okay.
I really got that joke. Oh my gosh, I'm so slow.
Well, at least you got it. Nobody else did. I think you and Ryan are the only one.
Wait, wrong one.
that would just stay the same, correct? Because it's being divided by itself.
That's correct.
And then you divide by the smallest number, right?
That is correct.
Would the first one need to follow?
So finish putting your units. So we have to put
Right.
sig figs.
The
So we
first
have,
one needs to follow. Yeah.
so how many sig figs should we have? Oops,
3.
3. So this should be an 8, right?
Correct.
Okay, it's not a pretty 8, but it's an 8.
Wait. So that first one, when you put it in the calculator, you get 4.98. 4.98.
Okay, so you tell me, is that close enough to a whole number?
So you could, okay, so if it's close enough to a whole number, you could just say it's going to be 5 carbon.
Yeah, because isn't it 4.98? You can't get any closer than that except for getting 5, right?
Okay.
Now, the rule of thumb is typically if you're 0.2 off,
Yes.
then that means, let's say if it was 4.8, then you're going to have to do our special magic multiplication, right? So you use that table. But if you're not 0.2 off, if you're like 0.1 off, then you can just round in that case. So if it's 5.1, then you just round to 5. Yeah. If it's 4.9, then you round to 5.
So, okay, so like the one next, the 8.64 divided by 1.24, you get 6.96. So you just rounded to 7?
Yeah.
So it's 0.1 off.
Yeah. It's less than 0.1 off, yes. Okay, piece of cake?
Yes.
Dr. Henry,
High five, Sarah. Yes.
does it matter which one you divide it by, or can you choose one you divide it by?
Nope, you always want to divide by the smallest.
Okay, thank you.
So who's the smallest?
Nitrogen.
Nitrogen. Okay, so let's make it a little more challenging, right? This is too easy. So let's say, now that we know the empirical formula, let's say we're given the molar mass of nicotine. Okay. So I'm adding this to our question. So now that Sarah has done all of the heavy lifting, what do we need to do next? So any ideas?
Are we in we're not in grams per mole, are we?
No, we're not in grams per mole, but what is the molecular, how does the molecular formula different from the empirical formula?
Because the empirical formula, you're looking for the lowest ratio.
And then that's usually given to us by dividing or trying to find a number that we can divide the molecular formula by, right?
Correct.
So like earlier we had C4H10 and we divided both of those by 2, right?
That's correct.
Okay, So, but then C4H10 was the molecular formula. So in this case, we're just going to be doing the opposite. So we need to find out what number do we need to multiply our empirical formula by to calculate, to determine the molecular formula. Jessica, are you giving them a hint again?
No, I'm not.
Uh-huh, sure.
No, I'm telling you,
that.
you have
I
smart
see that molar mass on
students.
the thing again. I don't know.
No, are you doubting your students, Dr. Henry? Wow, wow.
It sounds like he don't trust us at all.
Oh, it has nothing to do with me trusting you. It's me trusting Jessica. I see how she is. She's sneaky.
I don't blame you, Dr. Henry.
She's not private messaging us.
I am not private messaging anyone.
She did shoot me a text.
Don't
though.
be getting her in trouble, Dr. Henry.
What was that?
I said, don't be getting her in trouble. For Jessica.
Thank you, Kayla.
So, what do you guys think you're going to do? Since Jessica was giving you that hint.
I'm gonna use
I didn't hear it, Jessica. Can you repeat it again?
the molar.
What did I write? What did I write? Let me go back.
It's in the
I
chat
don't
window.
see anything.
She wrote like
I don't
molar mass like way long ago.
Like
It was like when class
But she
started.
was still trying to give you a hint, though.
Oh, I didn't see it. That's probably why I didn't see it, because I
She
logged on
thinks she's
late.
smart, right? She'd write it twice, so she's like, she knows it was coming up.
Is that so? Is this when we use the 6.02 whatever?
So that's right. You are going to use that. But first thing you need to do is calculate the molar mass of the empirical formula. Okay, Jessica, since you told them. So, can you calculate the molar mass of the empirical formula? If so, how?
I am not that far yet. I can't do this.
You can't do that?
No, I do not have the ability to do this.
You lie, because you did it yesterday, and you were just jumping in front of people. I have to shut you down?
Yeah, you did.
Mm-hmm. So if this is the empirical formula that circled at the bottom, how would I calculate the molar mass of of the empirical formula? Come on, wipe off those cobwebs. It was just yesterday.
Could you multiply?
What was that?
Could you multiply?
Multiply by what?
6.02.
Well, let's slow down. Let's save this part here for later. How do I calculate the molar mass of this compound?
Wouldn't you just times the 5 times the atomic mass of carbon on the periodic
What's the
table?
atomic mass of carbon?
12.
So, because we have 5 carbons. We have how many hydrogens?
7.
So,
And one nitrogen.
There you go, bro. Now it's clicking, huh? Your hamster wheel's going.
Oh,
Hey, go.
and we have 1 nitrogen. So 1 times 14.
Mm-hmm.
And we're going to add them all together. So I have 14 plus 7
21.
plus 60.
81.
So 81 grams per mole. Okay. So now what makes sense? We have this guy in grams per mole, and we have this guy in grams per mole. What do you think we're going to do with it?
Divide. Divide them.
Okay. So let's put the big guy on top. Oops.
So you're saying, Dr. Henry, that my molecular mass goes on top and my empirical mass goes at the bottom? That's what you're saying, right?
That's what it sounds like I'm saying.
Good question, Jessica.
So,
Thank you.
2.
okay. So then this gives me the integer that I'm going to be multiplying my empirical mass by, my empirical formula by,
Your molar mass?
to get my molecular formula.
Or your molar.
Okay. So if I multiply all of these numbers by 2, my molecular formula is going to be what?
C10, H14.
Stephanie has a question.
Okay.
He gave it to us, right?
It was given to us in
N2.
On the top.
nicotine. Oh,
Oh, I rounded. You can spank me for that. I got carried away. It should be 162.23, but it's still going to be about 2. Does that answer your question, Stephanie? Good job, Aaron. Did you sneak in the room or were you there before?
I've been here. Do I
I
came
mean, she came late.
Wait, I have a question.
Sorry, Aaron.
Who says I have a question?
Jamila.
Okay.
Where'd you get the C10 from? Did you?
Because 2 times C5 is what?
10. And then, so you multiply the 2 by the.
By all of the numbers here, right? And then that's going to give me, so this is going to be my molecular formula. Molecular formula.
Look, you have to draw a line all the way from there. So bad to understand.
And then this one is going to be my empirical formula.
Let's see, it's like 20 times.
See how that works?
Yes.
Are you with me, Stephanie? You need to get your mic fixed because it really hurts me a little bit not hearing your voice, you know.
No, you kind of missed a little bit.
Just a little bit, though.
Yeah, just a little bit.
No, doctor,
Yes, Andy.
where you get a 12 from? 5 times 12.
Where did I get the 2 from?
The 12. 5 times 12 equals 60.
Guys, I have 5 carbons. What is the molar mass of carbon?
The carbon, let me see. Oh, that's where you get from. Okay, 7, you get 7 times 1. And then you come back 1 times 14 again. I got it.
You got it.
Oh.
All right. Okay. Questions, concerns, Cash?
Are we gonna do another one?
Do another one.
Maybe we'll do an easier one because this is, this is pretty easy. It wasn't too hard.
Well, I'm just saying, like, if you're gonna have a hard one on the test, shoot me another hard one.
Oh,
Well, don't shoot me another. Show me another hard one. Don't shoot me one because I want to answer it because I really don't know how to do this.
So the easy one.
okay. So let's do the next example, right? I just made this one up on a fly. I wanted to give you. So this is a typically a hard one, right? But the other ones will be more reading, a little more fun. You're not going to get that till the next test. This one is just going to give you just to kind of get you. I want to get you a taste. I'm giving you a taste of the good.
Get my feet wet.
I'm trying to get you hooked. Hooked on chemistry. Okay, you guys ready?
Yes.
All right, let's do this.
Did everybody get a picture? Take a picture.
Hold up. Hold up. Let me take a picture.
Take a picture.
All right, I got it. We're good.
Okay, everybody's good?
I'm good.
Okay. Okay, so you guys are already familiar with this. So here's your problem. I want you guys to do it. Take a picture of it, hit your save button. On your annotate, go to annotate, hit save. I'm gonna put you in a group.
Oh, wait.
Oh, no.
And I want you to hash it out.
Take a
Where's
picture.
Jamie? Is Jamie here? Jamie and Kayla were going at it this morning.
Why?
Why? Over a problem.
We were not.
Mm-hmm. It was drama. You guys missed it. It was drama. Man, weaves were getting pulled off and everything. That was on Jerry Springer.
Oh my gosh.
That's too funny.
Okay, you guys got your picture?
So Kayla should be the expert then.
She's a pro.
No, I'm not. Don't be lying,
Okay.
Dr. Henry.
So I'm gonna put you guys in the break room. Are you ready?
Yes.
58.12.
15.
Oh. 5 molecular.
3. I think that's good.
Molecular. PB.
Okay, hold on.
Boom, 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 boom. Let's see. Let's see. Hey, Karina, you don't have to get upset and just write across my
My
board there.
bad. I forgot I was on the thing.
That's funny. You're just picking on everyone today, Dr. Henry. Damn.
Okay, you guys are good. Go to your rooms. I'm gonna put Roy in a room by himself. Well, since you guys are here, we can talk about it, and you'll just hear it twice. So, what do you guys think? How would you start?
Finding the molar mass.
Find the molar mass. So, what would be the molar mass?
I got it. Too much that. He's trying to go back. He's trying to go further. He's going last. Sorry, class.
Okay, molar mass. Molar
Are you waiting
mass?
for us to give you an answer?
Yeah, I'm like,
Oh,
you guys
so
expect
you
me to do
multiply
it?
2 carbons by 12.
So I have 2 carbons. So I go 2 times 12.
It's 24. And then you have 5 hydrogens times 1. So that'd be 5
Equals 29.
And then you divide 58.12 by 29.
Oops. That's a 9, really. Grams per mole. So you're saying I divide 58.
And that equals 2. And you multiply that by C2H5 equals C4H10.
Easy peasy. Chicken squeezy.
Yes.
But are they all going to be like that easy?
Maybe.
Or can they please be that easy?
Maybe for this test. One after this one is all gloves come off, because then you're going to be knowing even more, and you're going to be like, bam.
You know what I wish you would do, Dr. Henry?
What's that?
Like, you know what I wish you would do for like the exams?
What's that?
Is put like a little box thingy that says, Rolando, on this one you're supposed to do this.
So you want me to hand feed you, right?
No, I mean, not hand feed me, but sometimes I'll be like, I don't know what I'm supposed to do.
That's what this is that learning part of it, right?
Like big old words, and I'm like, I don't know. Like, am I supposed to use this? Do I need my periodic table for this one or not for this one? I don't know.
That's the learning part.
I guess I ain't learning nothing. And it's not your fault. It is not your fault.
I'm putting a shot collar on you.
At this time, and what like in the amount of time we have left, I'm willing to let you. I'll even sign a paper. You can put a shot collar on.
You'll sign the waiver.
Yeah, because I'm pretty sure like that's probably the only way I can learn. Just because I don't want to get shocked.
So you guys should have some of these in your homework.
No, just on top.
This is homework 8, right?
Homework 8.
Okay.
Okay. We got a few more. They're coming. Are they coming? Should I say, get your butts out here? Are you done? Does it pop up on your screen and flash?
Yes.
And I send you guys messages in your rooms.
Well, I would think it's done, but I don't know. Do we still have to divide it to get the smallest? Would it be C2H5? Then that pulls us back to our empirical formula.
Okay. So are we asking you for your empirical formula?
No.
And why would I go back to where I came from?
Okay. Because we're looking for molecular, correct?
That is correct.
Okay. We talked about that in our discussion in our group, and I was like, wait. So I'm like, doesn't we have to get the smallest? And we're like, oh, we're not going to empirical, we're going to molecular. And I said, okay. It clicks better.
Do this. I'll close all rooms. You're back. So, you guys got an understanding? Yes or no?
Yeah, that seems pretty simple.
Come back already.
Yeah, we've been waiting for you.
Buddy, they're old.
Did you get lost? I know the classroom is hard to find sometimes.
My
Oh,
internet.
my notebook over there again.
Okay, let's go.
Where are we going?
I'm gonna get food.
Oh, what are we getting? What are you buying us?
Oh yeah, hook it up, bro.
I'm in Armona, so I don't know.
Ooh,
In
that one
Aroma?
thing.
Armona?
Armona.
Yeah. I don't know what's around here, so I guess I'll figure it out.
You live by
And then, oh, they have ravens there.
I've had ravens, and
isn't it?
I wasn't very impressed.
Their
There's
chicken has
also
no flavor.
the carnero or carne. How do you
It's
say
pretty
car?
going. Yeah. Anyways, I'll log on my phone. I'm not gonna miss out.
Okay.
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 Hey, give me a burrito.
Gosh.
Okay. So, are you guys comfortable with this? Yeah.
Yeah.
Okay. Good. Good. So let's talk about balancing equations. You guys remember we talked about that ancient first day of class? We were balancing equations, right? You guys remember that?
Yes.
No.
Hasn't
Andy,
that
you
been
don't
kind of
remember your
weird?
name half the time, so it's not surprising.
I know.
Have we been balancing equations with like with the positive negative charges?
Well, no, that's balancing the formula. That's just the formula. Equations is everything.
Oh, okay.
I don't even
Okay.
know what is what anymore. You've thrown too much at me.
Honestly, me too.
I'm glad I'm not the only one that feels that way.
And that's all right. By the end of the week, have you guys looked at your first exam?
And I don't want to look at it again. But yeah.
But
Did you
if
finish
look at
taking
it-
them?
Wait. If you look at your first exam, you'll be like, how in the hell did I get this wrong?
Oh yeah.
Because you'll be like,
That's literally right after we're done with the exam. I'm like, fuck,
Yeah.
I knew this.
okay, you guys ready? So let's talk about, we're not going to talk about the stuff up here. So let's say we have this situation. We have C6H12 O6, and it reacts with O2, and it yields H2O, and CO2. So this here is a chemical equation. This is an unbalanced chemical equation. So you guys know about your subscripts, right? This defines what the compounds are that are reacting, right? We also have what we call coefficients. Coefficients will be, put this in a different color, will be numbers that will be in front of those chemicals, of those compounds. Balancing the equation is just trying to figure out what numbers are going to go in front of those compounds. Okay? Now the numbers in front of those, again, they're called coefficients. I can spell it. Coefficients. Okay. And you guys know that this side here is called what? We talked about this and it was on your last exam.
Reactants.
These are your reactants. And this side here is called
Products.
So remember when we talked about conservation of mass?
Yes.
Okay, what did I say about conservation of mass?
What you put in is what you get out.
What you put in, you must get out. Okay, so that's also going to make reference to the elements in this reaction. Thank you for the correction. Okay, I knew there was something missing. Okay, so what are the elements that are going to be on my reactant side? Just give me the major elements.
Hydrogen, oxygen, and carbon.
So we have hydrogen, oxygen, and carbon. I like to put carbon first because it spells cho. You're such a cho. Okay, so how many carbon do we have on our reactant side?
6.
6? Okay. So we have 6. How many hydrogens do we have on our reactant side?
12.
12.
How many oxygens do we have on our reactant side?
8.
Okay, what about on our product side?
1 carbon.
How many hydrogens?
3.
2.
Oh, 2.
3.
And oxygens? 3.
3.
Okay, so now I want you to think about this. Now think really, really hard on this. So does 6 equal 1?
No.
Okay, so since 6 doesn't equal 1, what do we need to do on the product side to make it so that we have 6 carbons?
Multiply it.
Multiply it?
Oh, no.
Or I
Yeah,
think we add a
multiply it by
coefficient.
what?
Add a 6.
6.
6. So I'm going to put a 6 for my coefficient here, right? So if I multiply this, if this means that I have 6 CO2s. So how many carbons do I have?
6.
I have 6 carbons now. Okay. So how many oxygens do I have on my product side now?
8.
Oh yeah, 8.
Okay. I have 8.
8.
Ooh, that's looking good. I have 8 and 8. That's already looking good, right?
Mm-hmm.
Okay. But these guys look like they're balanced. But what about this guy? Is this guy balanced?
No.
No.
Wait, Dr. Henry, how do you have
Wait.
8?
That's true. That is an 8. 6 times 2?
18.
6 times 2?
12.
12. We have 12? Okay. 12. 12 plus.
13.
So we have 13. I was like, man, that's too good. Okay, I can't do math today. 13. So we have 13 oxygen. So is it balanced? Is 8 and 13 the same?
No.
Okay,
No.
thank you, Jessica. Good eye, good eye. Okay, so these guys are balanced, but is my hydrogen balanced?
No.
Okay, what do I need to do to make my hydrogen balance on the product side?
6.
So put a 6 in front of here. Okay, so then I have 6 times 2 is what?
12.
Okay, and then I have 6 for my oxygen. 6 times
1.
1. 6 times 1 is what?
6.
Plus the ones over here.
12.
Plus 12. That's 6 times 2 is
18.
12. That's 18. Okay, so now I have 18. Is 18 and 8 equal?
No.
No.
Damn it.
So would you add
Okay.
a 9 to the other side to make to the other oxygen on the reactant side?
Okay, so you're saying I should add a 9 here?
Yeah.
Okay, so let's put a 9 here. 9 times 2
18.
plus 6.
24.
Oh, shit.
Okay, so that don't work, right?
No.
So let's think about this a little bit though, right? So if I don't have a 9 here, right? So I have 18 over here. Is that right?
Mm-hmm.
And this is my
The
only,
6.
well, and this guy, the carbons and the hydrogens are already balanced. Is that right? Is that true?
Mm-hmm.
Yeah.
Okay, so let's just do this. Let's say I take my 18 and then I subtract that 6. So I don't have to mess with this one at all. Okay? So I subtract 6.
Put a
What
6
is that
there.
going to give me? That's going to give me how much?
12.
12.
12.
12. So if I want 12 carbons, and this is 2 right here, so what needs to be in front of here?
6.
Okay, so let's see if we got that right. So 6 times 2
12.
12.
plus 6.
18.
Okay, so 6 carbons, 6 carbons. 12 hydrogens, 12 hydrogens. 18 oxygens, 18 oxygens. I have a balanced equation.
It's like a guess and check.
And this guy is understood to be 1, right? We don't have to put the 1 there. We just understand that that's 1. Okay?
So is it kind of just guess and check?
Yes. But there's logic to the madness, right?
Yeah.
Okay? So if I ask you on the exam, how many coefficients are in the reactants? What are you going to tell me?
6.
8. 7, sorry.
Okay, so I have 6. Somebody said 6.
Oh,
and I have 7.
You have the 1 in front of the.
That's right. You have 1 in front of here. So the correct answer is 7. Okay, so if I ask you how many how many coefficients are in the products?
12.
12.
If I ask you, what is the sum of all of the coefficients for this chemical equation?
19.
Piece of cake?
Yes.
Everybody else. I mean, Ryan says he got this. He don't need y'all.
I'm not on Ryan's level. Can we do another one?
Yes, we can. You ready for another?
Yeah.
Okay, so let's say we have, let's see.
What are you watching, dude?
Do you just come up with these, Dr. Henry, just like off the top of your head?
Yeah, most cases. Sometimes it gives me. This is how I did a lot of learning of chemistry by doing that. Me and my my study group, we would get together and then we just make up problems. Because back in the day, there was no Google, so.
That's right.
That was a long time ago.
Oh yeah.
Nerds. Oh my gosh, that's too funny.
It's so true.
She said that's what Nancy said in the chat box.
Oh, Nancy calling somebody a nerd? Come on now. I need my point. Give me my point.
And you still haven't given
I
it to
still
me.
haven't. Yeah, I have it posted here. I'm gonna wait. I'm just making you suffer a little bit. That's all.
Rude.
This is a.
That's an S for solid. That's an L for liquid. Okay?
I have a question.
Yes, sir?
Does the aqueous and the liquid, does that all play an effect onto balancing the equation? Or will we still balance it the same way?
No, you still balance it the same way.
Okay, you're just labeling it as an acid, liquid, and a gas, I believe.
Nope. That's an S.
Oh, okay. Okay.
Leave my S alone. Hating on my S. Okay. Are we ready?
Yes.
Yes.
Do it.
Okay, so what are we gonna do?
Will we label our elements that we have?
Okay, so tell me my elements.
Iron.
Iron,
Iron,
oxygen,
Oxygen,
hydrogen,
hydrogen,
and
sulfur.
sulfur.
That's it.
is that it?
Yeah.
Yes.
Okay, so the way that I always do it, I always find the one that's in one of the compounds. So on both sides of the equation, right? So if there's something that has in both of the compounds, like for instance, I have oxygen here and I have an oxygen here, right? So I save those for last, and I just pray that it all balances out so I don't have to do anything crazy.
Okay.
Okay, so what is an element that is in only one on each side of the arrow?
Oh,
Would it be the oxygen and the sulfur?
Okay, I'm gonna say that again. How many different
The iron.
Fierro.
iron, right? So iron would be the one I
Is
start
only
off with.
one.
So
Yeah.
I start off with the iron, right? Because here, Ryan, iron is only here, and
Okay.
iron is only here, right? Oxygen, on the other hand, is here, 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 and here, right? So isn't that?
Okay.
And so you want to try to make it easy for yourself. I mean, if you want to be hard and be difficult, that's fine. You like drama, that's fine. Okay, I like a little bit of drama, but not like this.
Dr. Henry, you like drama.
So,
Okay, so how many iron do I have on my reactant side?
1.
1.
How many iron do I have on my product side?
2.
2.
Okay, so we'll just go through and do them all first, and then we'll focus first on the iron. Okay, so then how many oxygens do I have on my reactant side?
5.
7.
7.
7.
7.
7, right? Because we know that 3, because you got to multiply that 3 times whatever in the parentheses. So that's 3 plus 4 is 7, right? What about my product side?
8.
13.
13.
Okay, 3 times 4 is what?
12.
Plus 1.
13.
So 13. Come on, Andy, you got to do that math. Don't give up on me there.
2, 3.
Okay, how many hydrogens on the reactant side?
5.
5 now.
Yeah, 5.
Okay, 5. Okay, and then on the product side?
2.
2.
Okay, how many sulfurs on the reactant side?
4.
4.
4.
1.
1.
Okay, Andy, why is it only 1? Why isn't it 4?
Oh.
Oh, it's 1. Yeah, because there's it's
Oh,
not
so-
outside of the parentheses.
That's correct.
Yeah.
Now on the product side,
8.
3.
Andy, you stop just yelling numbers out and look on the screen. There's no 8. You need a shot collar. I'm gonna purchase shot collars today.
This Vietnamese. Sulfur,
Something.
Okay.
Okay, you
Yeah.
guys got that so far?
Yes.
Okay, so now here's the hard questions. For iron, is it balanced on both sides?
No.
Who said yeah?
No.
Not me.
Andy probably.
It wasn't Andy.
Lower that, Bubba. That's too loud.
Okay, so we know it isn't because we have 1 on our product. On our reactant side, and we have 2 on our product side. So
can
it's
we
not
add
balanced.
Can we
So
add
what do I need to do to balance it?
Can we add a 2 for the coefficient?
Okay, so I'm gonna put 2 here.
Yes.
Correct.
Okay, so if I do that, then that's gonna give me 2 irons. Okay, how many oxygens do I have now?
Oxygen.
6.
So I have 3
6,
times 2, so that'll be 6 plus
4, 10.
So I have 10. Okay, how many hydrogens do I have now?
Eight.
So I have 3 times 1 times 2. So that's 6
Yeah.
plus
8.
2.
8.
8. And we haven't done anything to the sulfur. So are my oxygens balanced?
No.
No.
Are my hydrogens balanced?
No.
No.
Okay, so let's keep going. We got more work to do. And we know my sulfur isn't balanced. Okay, so if I want to balance my sulfur, because the sulfur is only here and here, right? So let's start with that one. If I want to balance my sulfur.
On your reactant side, can you add a 3?
So I put a 3 here.
Correct.
Okay, so then I have 3 times 1.
3.
3.
So that's 3. So that guy is balanced. So, but that's going to change the number of oxygens that I have and the number of hydrogens.
Correct.
Yeah.
Cross these out. So how many oxygens do I have now?
12.
So you said 12. So I have 12 here, right? So 3 times 4 is 12 plus,
2.
so 6. So 12 plus 6 is what?
18.
18.
Okay. Is 18 and 13 balanced?
No.
Okay. Now, what about my hydrogens? How many hydrogens do I have over here?
6.
So here,
12.
there's 6 here, and then 6 here. So that's 12. Are my hydrogens balanced?
No.
Yeah.
Okay, so then now we need to go to the product side and see if we can get everything balanced. Because we know we have our iron balanced and we have our sulfur balanced. Okay.
Oh, could we add a 6 coefficient in front of H2O to balance those hydrogens out?
Okay, so you're saying put a 6 here?
Correct.
Okay, that makes sense. Let's see if that works out. So this guy is now 12.
12.
How many oxygens do I have now?
No.
12. 18.
18.
I have 18.
18.
Oh, there you go.
Oh, so let's check it out. So I have 2 iron on my reactant side, 2 on my product side. I have 18 oxygens on my product side and 18 on my reactant side. I have 12 hydrogens on my reactant side and 12 on my product side. And I have 3 sulfurs on my product side and 3 sulfurs on my reactant side. Everything's balanced. Piece of cake?
Yes.
No, you give me 10 more questions like that. That's better.
Yeah, you have that in your homeworks.
That's homework 8, Dr. Henry?
That's homework 9.
Oh, okay.
9, we should be available.
Did I finish homework 8 yet? Let me see. Okay. Chemistry 101.
Dr.
Okay.
Henry,
Yep.
I have a question.
Yep.
So what if you have like a polyatomic on both reactant and product side?
If you have a polyatomic on both the reactant and on the product side, you can actually put them together. But often if you do that, it'll kind of throw you off if you have, like, say, the oxygen in another element. So I like to do it the hard way, but you don't have to do it the hard way. I'll show you how to do it the easy way too. So, but not yet. I want you to suffer. Got to suffer
Okay.
a
So
little
the
bit.
same problem from this morning, it was done differently, right?
What was that?
This is the same problem from this morning, it was done differently, right?
No, this is a different problem from this morning.
I have it
Because
right.
we had barium oxide. So we had barium hydroxide this morning, and we had phosphoric acid. You guys are doing iron 3 hydroxide, and you're doing sulfuric acid. I got to keep you on your toes, right?
Yeah, I was like, I came on just in time, so I have the problem written down the exact same way. And then we did the C2H5. We had the 2 carbons, the 5 hydrogens.
Yep. But if you remember, I think it was phosphorus instead of sulfur and barium.
Okay.
Yep.
All right.
You got to keep you guys that come to both session honest, right?
Yeah.
Yep. Okay. Questions, concerns, Cash? So, what would this guy be called if you're doing nomenclature?
Sulfate.
What that?
So what did you guys call it?
Sulfate.
You're just going to call it sulfate? I'm talking about the whole thing.
Oh.
Iron sulfate.
Iron 2, sulfate.
Iron 2?
Iron 3.
Iron 3.
Iron 3.
Iron 3.
621, I copy traffic. So
Sulfate.
Sulfate.
And phosphate.
Okay. Piece of cake. And this guy, even though I said it, we'll see how many people listen to anything I say.
Iron 3 hydroxide, I think you said. Something like that.
Okay. And then this guy.
So,
oh, well, is it hydro?
Acid.
Wait, no.
I don't know.
Hey, Ryan, I'm getting a shot collar for you too. That's 3 now.
Sulfuric acid.
You said sulfuric acid?
Oh my God, these freaking tones.
Okay.
Beauty saving lives.
Okay, piece of cake.
So if it has hydrogen, you don't put hydro.
No, not if it has hydrogen.
It has oxygen.
Oh, it's oxygen. Okay.
Uh-huh.
What is this guy called? Now, if anybody get that wrong.
Water.
Water.
I thought it was dihydrogen oxide, Dr. Henry. Why is it water?
Guys, we said so as chemists. We just go with water. Water's water. Don't fight the current.
Smart water.
Okay.
Okay, questions?
Concerns. Cash.
So if you see something like this, what is this?
That's still H2O.
Is that
Still water.
HOH?
So it's still water.
Yeah, because there's 2 hydrogens.
Was that a trick question?
That is a trick question. You wouldn't believe how many times, because we'll show you how to sit there and figure out who's going to pair up with what in terms of a reaction. And when I show you how to pair it up, people always pair it up and they'll put that and they won't realize that we're talking about water.
Oh, I see.
Thought I'd ask. Okay, do you guys have any questions?
No.
You guys are on top of it. You guys are ahead of the game. So I'm going to leave chapter 8 until tomorrow, mañana.